Greetings everyone. I am Muhammad Asim from University of Engineering and Technology, Texas. I will present the article Pattern Analysis for Biometric Authentication using Electrocardiogram Signal. These are the contents which I am going to discuss. Firstly, I will discuss what is biometric authentication and electrocardiogram. Following that, motivation of this research, and then literature review, proposed method, results and discussions, and finally conclusion and future work. To start with the introduction, first we need to know what is biometric authentication and electrocardiogram. Biometric authentication is the way of identifying someone's identity using their physiological traits. An electrocardiogram is the graphical representation of electrical activity of heart. Let's move on the motivation of this research. Biometric authentication was being done using traditional methods like alphanumeric patterns, fingerprints, speech recognition, and iris detection. And all these methods have some disadvantages, like alphanumeric patterns involve the risk of forgetfulness, and all other methods can be manipulated. Electrocardiogram counterweights all these problems and provides robust solution. This is the literature review. This is the work which has been done by other researchers. As we can see that many other researchers have used different data sets like PPG, EEG, different number of subjects and different methods to achieve maximum results. Here is the hierarchy of our post methodology. Firstly, we will connect Biopac MP36 system with subject to acquire ECG dataset. Following that, filtration technique has been used to pre-process the data. After that, discriminant features have been extracted from the pre-processed dataset, and then various classifiers have been used to train the model, and that trained model authenticate each subject. Now I will discuss each step of our post methodology one by one. To start with data acquisition, we have used Biopac MP36 system with SS2L leads and surface electrodes to acquire the dataset from 36 subjects, which include 22 males and 14 females. Age range was between 19 to 50 years and sample rate was set to 1000 Hz, which was provided by the Biopac system. After the acquisition of data, we segmentized the data for 10 seconds and total signal was 1947. All the dataset was acquired at a room temperature and pressure in sitting position. After the data acquisition, pre-processing needed to be done due to the presence of power line interference and low motion artifacts. We have used notch filter to remove the power line noise and bandpass filter to remove the low motion artifacts and to acquire the region of interest. Following that, we have extracted 18 discriminant features which include time domain features, morphological features, and cepstral features. Time domain features includes skewness, curtices, mean frequency, log energy, etc. And cepstral features includes MFCC and GTCC. And finally, base classifiers have been used to train the model, which includes spot vector machines, knife base, ensemble methods, and decision trees. That model classifies the data from all subjects. Spot vector machine outperformed all other classifiers and achieved maximum accuracy. Now we have walked through the proposed methodology. Let's move on the results and discussion parts. Here is the table 1, which shows the accuracy comparison between different classifiers. As we can see that spot vector machine cubic achieved 99.1% accuracy, spot vector machine linear achieves 98.9% accuracy, and spot vector machine quadratic achieved 99.2% accuracy, and other classifiers has been listed below. We have used cross-validation method to train the model, in which value of k has been set to 10, which means that 9 samples of each subset will be used for training and 1 sample will be used for testing. The reason why we used cross-validation method is that it is feasible for smaller dataset. This is the figure 7, which shows the accuracy comparison of different classes. Here is the table 2, which illustrates the comparison of our proposed methodology with previous literature. As we can see that Liberty used PPG signals as dataset and achieved 99.16% accuracy, Huang used PPG signals as datasets and achieved 98% accuracy, and Abdullah used EEG signal for dataset and achieved 81% accuracy, and ECG signal used by Hussain and achieved 95.6% accuracy. And our proposed method used ECG dataset for data and time frequency and septal features and achieved 99.2% accuracy. After this research, we have concluded that biometric authentication systems delivers phenomenal results even in noisy conditions, and physiological signals are highly reliable for biometric authentication systems. In future, we will enhance the dataset and will use different physiological traits like PPG and EEG. These are the references which have been used for this research. Thank you.